heat, pressure. You wake up, reset the variables, and prepare the system. There is nothing better than the first cup of coffee. It just needs a tiny splash of cream. Actually, maybe a little more.
Ruined.
I hate when this happens. I just want to take it back. But have you ever noticed that you can't? It took me 1 second to pour this, but if I had a billion years and a microscope, I could never separate the milk back out from the coffee. I can mix it effortlessly, but the universe forbids me from unmixing it? Why? Why does nature allows us to make a mess but never fix it? The answer isn't just about coffee. It's a reason you grow old. It's a reason time moves forward. And it's a reason everything you love eventually fades. Physics laws don't care. If a magician takes a shuffle deck and instantly turns it back into a perfect order, you know it's a trick. You know they use a sleight of hand. But there is a crazy part. It is not impossible to shuffle a deck back into the order. And shuffling these cards for, well, trillions of years, eventually, purely by accident, they would land in perfect order. It's just incredibly, really unlikely. So, is the coffee the same? Is unmixing the milk just a matter of luck? If I stir this long enough, will it eventually unmix itself? Here is the problem. The laws of physics don't actually care about time. If you watch a video of a ball flying through the air and then you watch it in reverse, the physics works both ways. Gravity, motion, energy. The equations work perfectly in either direction. But if you watch an ice cube melt, you know which version is real. You never see a puddle of water suddenly snap together and turns into ice. And this is the paradox. The fundamental laws of physics treat the past and future exactly the same. They don't have a direction. So, if the laws of physics don't care about time, why does all things in our life only moves in one way? Time, the arrow. So if physics works both ways, what is the difference between the past and future? The difference is this hidden quantity. In the past, the entropy was lower. In the future, the entropy will be higher. It is not just you and your coffee. It's the ice on the poles, the burning of the sun, and the expansion of the entire universe. Everything is sliding from order to disorder. But it leads to a strange question. If everything is getting messier, that means yesterday the universe was tidier than today, and billion years ago it was even more tidier. It means that at the very beginning, the universe must have started in the state of insane, impossible order. Why? We actually don't know. We just know that we started with a full battery and we've been draining it ever since. This flow from order to chaos is what we call the arrow of time. Think about it. If entropy didn't exist, if time didn't have an arrow, there would be no difference between yesterday and tomorrow. You would be able to remember your future just as clearly as you remember your past. Entropy, the face of disorder. So why is this concept called entropy usually buried in textbooks about thermodynamics? Because it started with heat. Look at the box. On the left, we have hot gas, high energy, high chaos. On the right, cold gas, low energy, more order. As long as they are separated, the system has a structure. It has a story. But the moment I remove the wall, the heat rushes into a cold. The fast particles smash into the slow one. The system sneaks equilibrium. It seeks the state of maximum disorder, and once it mixes, it will never separate again. If I show you these two boxes, and I ask you which one came first, you don't need to be a physicist to answer. You know the filled balloon came first. Why? Because compressed air inside the balloon is highly specific organized arrangement. It's unlikely. Air spreads evenly through the box. This is the most likely. This is the boring state possible. Nature always pushes from the unlikely to the likely. This is the scary part about high entropy. It looks the same. If you look at this screen of random static maximum disorder, doesn't matter where you zoom in. The chaos at the top is identical to the chaos at the bottom. But look at this apple. This is low entropy. It has a structure. The skin is different from the seeds. The stem is different from the flesh. Order allows for difference. Entropy is the enemy of differences. Entropy wants to grind the apple, the balloon, and the hot and cold gas into a single uniform gray soup. And that brings us to the terrifying conclusion. If the universe is continuously increasing in entropy, if it is continuously moving from structure to sameness, then eventually everything we see becomes that gray soup. The end of the world. So, if a box of gas always seeks to mix and become uniform, what happens when the box is the entire universe? Well, the universe is trying to do the exact same thing. Wants to be a smooth, boring soup. Now we see a structure. We see stars organizing into galaxies. Looks like order, but look closer. When two galaxies smash into each other, they aren't building something complex. They are blending. They are mixing, just like the milk in the coffee. Now we see a structure. Gravity is pulling everything into a bigger, a smoother, more uniform pile. And here the strange irony. In a perfectly ordered white wall, every point looks the same. If you zoom in on a perfectly disordered wall of static, every point also looks the same. In the end, maximum chaos and perfect order looks strangely identical. They are both empty. They are both silent. As entropy increases, the space between things grows. Eventually, stars will drift so far apart that their light will never reach each other. Every galaxy will become an island, completely alone in the dark. So this is our story. It started with the Big Bang, a moment of intense, concentrated order. Then that order shattered into energy packets. Those packets formed galaxies. And now we are slowly drifting toward the final state, cold, dark, uniform. That sounds like the end. But what if it's actually the beginning? The next Big Bang. After the stars drift apart and die, the only things left will be the monsters, black holes. The small ones will eat the dead stars. The big ones will eat the small ones. Eventually, the universe will just be a graveyard of supermassive black holes sitting in the dark light years apart. But even the monsters aren't immortal. Stephen Hawking taught us that black holes leak. They slowly radiate energy back into space. It takes trillions upon trillions of years, but eventually the last black hole will evaporate away. And then that happens. You're back to the paradox. The universe now filled with nothing but uniform radiation. No mass, no time, no clocks. If you zoom in, it looks the same everywhere. If you zoom out, it looks the same everywhere. Does that sound familiar? Infinite disorder looks exactly like infinite order. Some physicists believe that when the universe forgets its own size, when there is nothing left to measure the time against, this end becomes a new beginning. So the next time you pour cream into your morning coffee, just remember, you aren't just making a perfectly good drink, you are participating in the inevitable decay of the entire cosmos. Enjoy while it lasts. And if you want to delay the heat death of this channel, hitting the like button actually helps a lot. A lot, you know what am I saying? Thanks for watching and I'll see you in the next one.